This is part 3 of the series of scaling in the cloud. There's an introductory video that will kind of explain the general concept into a high-level comparison. And in the case of GCP, you used managed instance groups to handle VMs that are scale up and scale down based on load. So in this video, we're going to demonstrate the GCP managed instance groups, and we're going to go through the same tasks that we went through the other ones. We're going to deploy our simple Flask-based microservices on GCP VMs. We're going to utilize Firestore as a document database to store data. It's a very simple usage of Firestore. And this is comparable to Cosmos DB and DynamoDB, the native document databases and the other providers. Then we're going to create a VM image of the deployed services using Packer. Then we're going to configure a managed instance group and enable automatic scaling using Terraform. Now, this is just like the other ones, where we're going to have a target of 2 instances starting out with a minimum of 2 instances and then a maximum of 4 instances. And what will happen is if the CPU goes above 60%, it will add units. And if the CPU goes below 60%, it will remove units. And so we'll simulate that load with the stress command like we did in the other ones and watch it scale up. And then we'll let it settle and have it scale down. At the end, we will clean up the resources so we're good stewards of our cloud accounts. So the first thing is that we have this diagram, and it's much simpler than the other diagrams. What you have is you have a cloud load balancing, an application HTTP load balancers is global. Then we have a managed instance group that manages the instances based on the rules we just talked about, min of 2, max of 4, and scale up at 60%, scale down at 60%. And it's connected to the candidates table in Firestorm. So that's a very simplistic sort of diagram, but that seems to be the vibe I'm getting is keep things simple and elegant in GCP as compared to the other providers. And when we get to the end, we'll talk about some of the differences in the providers, and I'll highlight that. So the next step is you need to go through the prerequisites. Now, there's a couple of prerequisites. Obviously, you have to have a Google Cloud account. The free account, or the $300 they give you, should work fine for this exercise. You need the G-Cloud CLI, you need Terraform, and you need Packer. So there's a video that describes how to do that. Now, what's different about GCP is it doesn't do it through environment variables like the other two. There's a special JSON file when you create the account to use Terraform and Packer. And so that is a difference. So we will kind of go through that in the setup. We're going to have to upload our credentials JSON into the project. And it's get ignored, so it's not pushed, but that's how we do it, is that JSON file. So I'm assuming all that's been done at this point. So now let's start with building the repository. So what I want you to do is I have a Ubuntu development environment. Windows will work as well. I'm going to copy this, and I'm going to pull my project in. All right. So in the project, there's this special script for all of them called checkenv, and it's going to say, hey, man, you do not have a credentials JSON. So I have one sitting around on my laptop, so I'm just going to upload that version, credentials.json, hit OK. And of course, I put it in the wrong location. It should go here, so let me move credentials here. So I should see it here, and now I should be able to do checkenv build. The other thing that is interesting with GCP, and we'll talk about it in the comparison, is there's certain APIs you need to have enabled, and I do that via script. I've experimented with Terraform, but for these simple examples, it's better to just put it in a script. So I'm going to go API setup, and that will go in our projects and enable all the APIs that we need to use. So at this point, we've got our checkenv script run. We've done the API setup. Now we should be able to do apply. So I'm going to apply it, and this takes a bit. So what I'm going to do is minimize this and talk about all this is document here, the build process. The build process is just like the other environments. It's divided into three phases. The first one sort of builds the underlying network of infrastructure, security groups. I think there's a NAT gateway in here because the VM instances are not publicly enabled. Then we use Packer to create the VM images using the Flask services. And then the final phase is we configure that managed instance group using the VM image from phase 2 along with the scaling policies. So at this point, what we're going to do is we're going to pause and we're going to let the build finish. Okay, now that the build has complete, what we're going to do is take a look at the what got built. So the first thing I want you to do is to copy and paste this URL here. And let's go to a web browser and let's just put that in. And what you're going to see is the results of the health check, good to go. And I'm going to hit refresh, 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 refresh. And you see it's going to bounce between the two services. The load balancer is spreading the load. So that's the health check. So if you got that, let's now bring up the GCP console and walk through what got built. So you log into it, make sure you've selected the project that you're working with. And what I'm going to do is go to VM instances. The first thing it's going to show you the managed instance group. So you click on that, and this is the instance group. And we'll double click on that, and you can see we've got on. So if any of those are unhealthy, it'll be replaced. And we have a min of 2 and a max of 2. And then we got the existing ones that are running. So there's also details on that, which will give you a little more information. Again, 2 instances. It's spreading across 3 different zones. So when we get to the point where we've bursted up, when we run this just command, we should see it in 3 zones. Then we've got the auto scaling policy, where we have a minimum of 2, a maximum of 4, and then auto scaling signal of 60%. And this is another one of those things where GCP seems to simplify things. And the other cloud providers, you can have the downscale and upscale can have different CPU utilizations. This is more of here's the target and it's going to handle it. So again, it's another one of those things where they're trying to keep things simple and elegant. And so then the final part is the down. It's going to go and remove the instance and replace it with a new healthy one. So that's it for the VM. The next thing to look at is load balancing. And you can see we've got the one load balancer, and the global HTTP load balancer is kind of funky, a special case. We'll talk about that when we get into the GCP specific things. And essentially it's I think just the artifact of trying to keep things simple. Most cases in my professional environment, you would use a VPN and you wouldn't use a global one, but this is just for the learning activity of learning how managed instance group works. So there's the load balancing. Now I'm going to go to the document database. Let's go to Firestore, and you'll see the default database for this project. And then there's the candidates. And when we do when we test the endpoints with Postman, we'll come back to this and we'll see that it changes as we add data. And the last part of the environment is let's go to VPC networks. And I did create a network just for this project, Flask VPC. And it's got one subnet. So again, it's much more simple compared to the other environments. And I think that's just what GCP does, is kind of make simplicity and elegance sort of a value that they have for a lot of things. So that's it for what got built. The next thing we're going to do is we're going to test the services. So what I'm going to do is I'm going to go back to the environment, clear. Validate Postman. And in Postman, I'm going to put in, see that it's running. I get the same result as the web browser. 2 and 3. And so let's go to the other endpoint. So the other endpoint there is candidate. And if I put in John, it should say, there's no John. So now I got to put in %20 Smith. And it'll show you John Smith. So the other thing I can do is I'm going to add a series of things. I got to change it to post and do homie1. Let me do homie4 and not least homie5. And then if I go back to candidates and I change it to get, hit send, and you'll see it shows all of them. The other thing I'm going to show here is we're going to go and look at the document database. So I'm going to go back to here and do Firestore on the database. And now you'll see all those things I just added. The next thing we're going to look at is we're going to run a load on the servers. And we're going to use stress. There's information in here about the specifics in the setup. We've kind of covered it, but there's a lot more detail in here and the workflow of scaling. So what I'm going to do is I'm going to do the stress command. And to do that, I'm going to go back to the console. And I'm going to do VM instances. And I'm going to go to my instance. And this is the equivalent of Bastion SSM. It's also much simpler in GCP. It just works. So I'm going to connect using an SSH client. Bastion in the other environment. So it's going to start. It's got a bunch of prompts and it says, hey, you really want to do this? 0% CPU. So I'm going to do stress-c 2 ampersand and top. And you can see it's immediately gone to 100%. So that's the first one. I'm going to go to the next one. It shows 0. I'm going to do stress-c 2 ampersand. And then I'm going to do top, and it should be at 100%. So now we need to wait, and I'm going to go to the managed instance group again. Instance group I'm interested in, and I'm going to go to monitoring, go up, but it's going to take several minutes for it to kick in. So this is what we're going to watch, and then once it kicks up, we're going to see the number of instances go up. So let's pause right here and wait for the stress to do its job. Okay, so for scaling up, you don't have to wait too long. GCP is pretty aggressive of scaling up. So you can see that my CPU went above the limits I've set, and then it scales up to 4. So if I go back to the overview, you should see 4 instances that are all sitting there. And if I hit refresh here, you can see that it's going to go across those load balancers, or across those zones. So again, it's also 3 different zones. So it does a default spread algorithm to try to spread it across as many zones as possible. So that's it for the scaling up. So now let's go back to the instances and let's hit Q. Let's foreground the stress command, hit Control C, top, and you can see we're back down to 0. So let's quit, exit. Then let's go back to the other one, same deal. Let's quit. Let's foreground, Control C, and then top. They should click. No, it's not quite 0. All right, 0. Now let's exit. Now we need to go back to monitor a bit longer. So we'll hit pause right here and we'll let it scale down. Okay, so you can watch this as it's going on, and what you'll see is the monitoring will trigger, and you see it's below, and now we're in a period of transition. So you'll see this little transition thing going here. So it's going from two, it's removing two. So this takes a few minutes to run. So we'll pause. Okay, I've given it time to, but here's some things to notice. Okay, GCP does a great job of scaling up. I mean, quickly. It's like, okay, you've reached your alarm, and it very quickly goes back up. So on a flip side, scaling down is it's much more conservative about removing units. You can see we were out of the capacity way here, but it took this long for the system to respond to it and bring the number of instances down. And so this goes to the simplicity of GCP and trying to keep things elegant. You just give a target of 60%. And there are options for controlling how long this period is, but for the most part, you just don't choose it, and it does a reasonable kind of guess as to what you want. Now, if you look at the other providers, we had to configure the exact period of times that would trigger an upscale and a downscale. GCP, I can set those in more complex scenarios, but if I just say, hey, 60% target, this is what it does, which is pretty close to what you would want. So if you go back to the overview, you can see it's gone back down to 2. So I believe that's it for the presentation. So what we're going to do is we're going to start the destroy script. Now, at this point, you could go make some changes. You could change some stuff to the Flask image. You could change your infrastructure. You could do anything you want, and you should be able to rerun that apply script, and it'll pick up the changes and your playpen. So feel free to make this, make changes and play with it. This is a public template repository, so you can clone this and make it your own. I'll do destroy. And the differences between GCP and the other one. And the first one I keep alluding to is GCP seems to have this sort of vibe of let's keep things simple. And to put that another way is don't let the complex use cases pollute the simple use cases. Yes, you can do complex stuff in GCP just like you can with the other ones, cloud providers. If you're using a VPN, if you're connecting different networks, if you have a hybrid cloud situation, you're going to have to know routing rules. You're going to have to know networking. You're going to have to know, I guess, Transit Gateway is the network connectivity center, and GCP, you're going to have to know all that stuff. Then it gets complex. And I think the complexity is probably on par. But what they've done a good job of is not letting those complex use cases pollute the simple ones. We talked about the simple scaling rule. We'll talk about the sort of the global, if you're just doing simple cases. So there's issues after issues where they've chosen sort of like simple cases. The second thing is subnets work more like Azure rather than AWS. The driver of subnet segmentation isn't availability zone, it's function application. And so in this example, we only have one availability zone or one subnet, and it spans 3 availability zones. I just thought of something else on the simplicity is the ability to connect to your instances. On the other environments, you have to have Bastion in Azure, or you have to SSMM configured with the right role. This just works. You know, you can connect to your VM instances from the console like we showed with the stress command. So that's another example of GCP trying to keep the simple cases simple. Setup is a bit different in GCP. In the other environments, you use a lot of environment variables. There's the ARM environment variables and the AWS environment variables. With GCP, you have that JSON file, that complex JSON file that you create, and you put that in the project home, and you authenticate against that. In this example, I use a global HTTP load balancer one, and GCP has specific semantics for that. I think you'd probably use a zonal load balancer example. And one way that you can kind of think of it as being a little funky is you only have a IP address. And if you go look at the other ones, like AWS, AWS gives you a public DNS entry. Now, would you ever use that in a real world example if you had public facing services? No, you would buy a domain name. You would use Cloud DNS or Route 53 or Azure DNS to deploy your domain name, and you would do it that way. And in a private situation, you use a private hosted zone. So even these examples, even though they have a DNS name, they're probably not realistic examples because you would manage this differently. And so the last thing that's a little bit different is you've got that API management issue. In my examples, I do API management as part of the project setup. You could certainly put it in Terraform. I think you have to segment it a little better in Terraform because I was trying to keep my Terraform phases to a minimum for learning purposes. And the reason you do that is because if you destroy the Terraform, it destroys the API or disables the API, and there's like a couple of minute lag. So if you're doing rapid development, if you apply, destroy, you may get in a situation where it's like waiting for the APIs to become active. So that's it for the GCP example.